Hello and good day. Here we are in Algebra, covering our first objective of the year, CO1, classifying a number as rational or irrational. Now, yesterday, I showed you all the different symbols that you might see on these lesson pages, and one of them was that wise old owl. And the wise old owl indicated there's a definition, something that we need to define. And we start right off the bat with rational numbers and irrational numbers. Does anybody know what makes a number rational? If not, that means we're all going to learn something new today. That's fantastic. So a rational number is a value with a decimal that ends or repeats. A value with a decimal that ends or repeats. Remember all those comments about my handwriting from the survey? Sorry. Okay. But a value with a decimal that ends or repeats. So let's consider a value like 7. Is that a rational number? Peter?
Yes.
Why?
Because it can be a decimal.
Right. It's not written as a decimal, but it can be. And what would it be as a decimal, Peter?
7.0.
Very good. 7.0. Does that decimal end or repeat? It ends, right? 7.0. Done. Okay. In fact, we don't even have to write it as a decimal. It could just be 7. Okay. But it ends. It's done. So that would be a rational number. Something in decimal form. How about negative 8.163? Negative 8.163. Is that rational? Does the decimal repeat? Sepa? It ends, right? Negative 8.163. Done. So that would also be an example of a rational number. How about a fraction, such as 3/4? Is the value 3/4? Notice I didn't say a number with a decimal, because not all numbers are written as decimals. I said value. Is the value of 3/4 rational? Joey?
Yes.
Why?
Because you can convert it into a decimal.
Because as a decimal, 3/4 is 0.75, same value, right? And that decimal ends. So all three of those, 7, negative 8.163, 3/4 would all be examples of rational numbers because the decimal ends. What is the mathematical notation to show that a decimal repeats itself? Blake? Right. So if we had something like 10.23 with the line over that decimal is really 10.2323232323232323 and forever. Okay? The decimal doesn't end, but it does repeat, and therefore it would also be rational. Most of the values that you've worked with up until this point have all been rational numbers. Okay? Irrational number. Irrational kind of sounds like the opposite of rational. So if a rational number is a value with a decimal that ends or repeats, what would an irrational number be? Blake? A value with a decimal that does not end. I'm trying harder to write clearer here. Make my second grade teacher proud. That does not end or repeat. Okay? It's a decimal that goes on forever without repetition. Probably the most famous irrational number. Anyone have a guess? What's a number that doesn't end, does not repeat? Adam? Pi, exactly. Okay. Pi is an example of an irrational number. We have a symbol for it because it's very commonly used. You probably round it to 3.14 also. But I've got a poster here with like the first 100 digits of pi there. But it does continue on and on and on. Okay. We have it computed out to like 2 billion places, and there's still no evidence of repetition, and it hasn't ended. So onward and forward we go. What's the mathematical notation for a decimal that does not end, that goes on forever? We've got the line for if it repeats. What's the notation for if it goes on forever? Do you know? Yeah.
3 dots.
The dot, 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 right? Your parents send you a text. How was school today? You respond, fine, dot, dot, dot. What does that mean? There's more to it, right? there's something there that you're not saying. So if you see that, if you've got like 2.37104 dot, 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 that means it continues on forever, does not end, and it does not repeat. Okay? That's the mathematical symbol for that type of decimal. Questions so far? Okay. I also have this little key point here that talks about non-perfect squares. Maybe you've heard the terms perfect squares and non-perfect squares before. We'll get more into this in actually CO2. But what is a perfect square? Give me an example of a perfect square. Gino? 16. And when we talk about perfect squares, we're actually talking about the root of that number, the root of 16. What makes 16 a perfect square? Yeah. Right. 4 times 4 equals 16. The root of 16 is a rational number, 4. Okay? If I give you 16 dots, can you arrange them to make a square? Yeah, a 4 by 4 square. Right? 4, 4, 4, and 4. Give me another example of a perfect square. Perfect square. Caleb.
4.
Sorry?
4.
4 is a perfect square. The square root of 4 is also rational. It is 2. If I gave you 4 dots, you could make a square. A 2 by 2 square. An example of a non-perfect square, and I'm going to give you one to start with here, would be something like the root of 8. If I give you 8 dots, you can't make a square out of that. You can make a rectangle. You can't make a square. Okay? It is a non-perfect square. And the value of the root of 8, if you type it into your calculator, it's going to be something like, 2.8315. I'm making these up now because I don't really know, but it's going to go on forever. Okay? It's going to fill your calculator screen, and it's going to go on forever. The root of any non-perfect square will always be irrational. Okay? There's no number that when you multiply it times itself equals 8. And that's what makes it a non-perfect square. So what's another example of a non-perfect square, Peter?
13.
Sorry? 13, right? Yeah. Obviously, any prime number is going to be a non-perfect square because by definition, if it's prime, its only factors are itself and 1. Okay? Another example of a non-perfect square, Blake? 50 is a non-perfect square. No number times itself equals 50. If I give you 50 dots, you can't make a square. You can make a 25 by 2 rectangle. You can make a 5 by 10 rectangle, but not a square. Okay? How I want you to defend your answer for your homework for this page is actually explaining why you picked the classification that you did. If you say the number is rational, how do you know the decimal ends or repeats? If you say it's irrational, how do you know? Why? Is it a non-perfect square? Do you see the dot, dot, dot? Is it pi? Some sort of defense. So if for your homework, when I come check this in, if all I see is a word written down, you didn't meet the expectation. The expectation is you classify it and then explain why. I'm not looking for a whole paragraph essay why, right? Just a little blurb as to why. So let's take a look at the first row here and pick one. Oh, I keep forgetting. I've got to put the pen down before I scroll, otherwise it doesn't recognize. There we go. Pick a number, pick a value from the first row you'd like to talk about together here. Caleb. Square root of 36. Okay. Is that value rational or irrational? And since it's a root, really we're thinking about, is 36 a perfect square? William.
Rational.
It's rational. Why? What is the root of 36? 6. The root of 36 equals 6, and so it is rational. And your explanation simply needs to be, it's 6. Right? How about one from the second row you'd like to talk about, like to do together? Peter?
3.1211.
The last one. 3.121121112. Dot, dot, dot. Rational or irrational? I mean, I definitely see a pattern there. But Joe? It's irrational. A pattern is not the same thing as repetition. The pattern seems to be you've got a 1, then a 2, then 2 1s and a 2, then 3 1s and a 2. That's not repetition. Okay? Plus, we have that dot, dot, dot there, which tells us it does go on forever. Maybe it continues this pattern, maybe it doesn't. We don't really know. Right? But it's irrational, and the reason why it does not end. Okay? Yeah, Blake. Sure. It's true that math people are inherently lazy people, myself included, because we're always looking for like the fastest way to get an answer. Like we do the math in our head, we want the most efficient way. Let's just get this done. So yes, never be afraid to ask on how to get something done quicker, and we'll see if it's acceptable. I mean, work still needs to be shown, and that can be tedious, but the beauty is once you understand the work and then you can do the work mentally, then you can skip it, but we're not there yet. Okay? So those 11 are homework. The 9 that remain are homework for Monday. Then the bottom section here looks like this. Oh, the pen. Oh, that's going to be a year-long struggle, I feel like. What am I doing now? Here we go. Back up here. Directions. Answer each questions. Mr. Happy Pencil, this is your homework. It says, write the value of 7 3 ways. As an integer, as a fraction not in simplest form, and using a square root. As an integer. Do we know what that word integer means? Couple hands. Yeah, James?
A negative.
It can be. Doesn't have to be, though. But negative numbers are part of the integer set. Miranda? Yes. Essentially, it can be a positive or negative non-decimal non-fraction. So the integer way to write 7 would just be 7. Okay? But then a second way, write the value of 7 as a fraction not in simplest form. So you're writing a fraction with the value of 7 that not in simplest form, and then using a root. So what square root has a value of 7? Are these questions or are they answers? If they're answers, put your hands down. Question, Caleb.
So are you trying to, for the square root, make it into the number 7?
Right. So you're looking for the root of what equals 7. That's what I'm looking for. Next question. In our number system, are there more rational numbers or irrational numbers? Think about that. In our number system, Are there more numbers that are classified as rational or more that are classified as irrational? And then lastly, for review, describe whole numbers and integers. We already talked about integers. Whole numbers are a subset of that. It's a more specific set. Okay, see if you can look back in your notes from last year perhaps, or use the Google if you're not sure to define that. And that's it. Starting rather painless, I think, with CO1. Question?
For the second one, do you have to explain why there's more rational?
Yes, you should always be prepared to defend an answer. Yep. Explain your reasoning why. Okay. Other questions, comments, concerns, complaints, compliments, congratulations, or criticisms? We didn't talk about this before we started recording, but that's okay. We can practice on the fly here. My traditional sign-off, I don't really have a great sign-on, but my sign-off, I always say, that's how you math. Okay? That's how you math. When I say that's how you math, your response in unison as a class is, don't forget to like and subscribe. Okay? So I'll say, that's how you math. You say,
Don't forget to like and subscribe.
that wasn't bad. Okay? Now let's make it official. That's how you math.
Don't forget to like and subscribe.
Beautiful, folks.